This is the object, a hole punch, which I propose to partially recreate in 3D. I want to capture this component here, in blue. It has good characteristics for scanning, including various geometric elements that will help the scanner align itself, preventing it from getting lost during the scan. The material, while slightly shiny and reflective, is not overly so. The finish appears to be powder coating, and as such, it is slightly matte. As we've seen, several factors make an object a suitable candidate for scanning. However, this is not usually the case. People don't typically look for objects that are easy to scan, like those that often accompany scanners. Instead, they usually need to scan a specific object that might have any type of finish. For now, I'll set the hole punch aside. Let's move on to the scanner to demonstrate some of its features. I'll try to do this in a way that avoids reflections from the environment, but I'm not sure if I'll manage. Very well, here we have the scanner. Key things to highlight. Notice that we are currently in HD mode, but there is also a fast mode. I'll now go to the options menu to show you what's available. We have object scanning and people scanning, portrait mode. Here, I'll increase the resolution, which immediately jumps to the maximum. Notice the value presented, 0.1 to 0.25 millimeters. This is the minimum distance between points that this scanner can extract. I'll leave it as it is. For this object, I don't want to capture the texture. It's simply not relevant. Scrolling down a bit further, I'm not sure if you can see everything, but we have the option to align based on the object's shape. However, alignment based on texture is also available, but only if you enable the texture capture option. At that point, alignment could be performed using both textures and shapes. I'll enable it just to show you that this option is now available. I don't want to use this on this piece because it's not necessary and would only make the final model heavier. Lastly, we have alignment via markers, in case you're using a device like this one, which comes with a disc containing several markers. These markers are reflective and assist in the alignment process if this option is enabled. For now, I'm not going to use them, but I'll eventually scan this piece using this table, just not yet. In this case, I want to start scanning the blue component entirely by hand, since this scanner is also designed for manual use. That's how I'll begin. I don't think there's much else to say about this area of the scanner's interface. Over here, we have some critical features, and now I need a few seconds to find the best position to show them to you. I'll place this object, my pointer, which is a pen, as an example. As you can see, it's highly reflective, and we'll see how it appears on the scanner. Okay? It's already in front of the scanner. Notice that the object is not being correctly represented. Also, observe how it's appearing. After editing the video, I'll place the hole punch to compare how the scanner handles these two surfaces. One thing you must do before starting the scan is activate the light exposure option. Notice the blue zones indicating underexposed areas and the red zones indicating overexposed areas. It's uncommon to achieve a completely balanced situation where neither occurs. A bit of overexposure or underexposure is normal. Try to find the best possible balance. This scanning distance D-off option allows you to adjust the depth of field. Watch as I adjust it. You're essentially defining how far the scanner can see. Here, it doesn't reach as far. There, it reaches further back. However, note that the area it can scan or see is quite small. Why? Because we're in HD mode. If I switch to fast mode, which I won't because it takes some time to change modes, you'd see that the area is substantially larger. To scan a large area in HD mode, the scanner would need larger sensors and much greater processing capacity, like professional grade scanners offered by Shining 3D. Since I'm scanning an object without texture, capture enabled when I press here, the data quality indicator option is supposed to be active by default. Let's see. And indeed it is. However, if I were capturing textures, as I showed earlier in the main menu, you'd need to enable it manually if you wanted this option. The reason is simple. The two overlapping modes can be confusing. Everything is ready. The only thing left is to move the object slightly forward or backward to place it in the optimal position for scanning. You'll see this green bar moving. The green bar indicates the optimal distance between the part and the scanner. Perhaps my hand will work better than the pen. There it is. Here, it's very close, but within the acceptable range. As I move my hand farther away, you'll see the bar rise, indicating that the object is moving farther from the scanner. Right? And there's my hand. As long as it's in the green zone, it's fine. It doesn't need to be in a specific spot within the green zone, just within that range. That's great. Very well. The object is already there. I'll adjust it as I usually do, trying to ensure the object is correctly exposed in terms of lighting, using this bar again. It seems good now, at least decent. Let's begin scanning. To start scanning, I need to pay close attention to two things: the screen and the part itself, to avoid mishandling it. With practice, you'll realize you don't need to look at the part because all the information is on the scanner's screen. But initially, you should keep one eye on the screen and the other on the part. Just don't swap your eyes. This is one of those things that seems easier than it really is. The bar may suddenly rise or fall. If it goes out of the ideal range, the scanner might stop capturing the object, and it's likely to lose reference, requiring realignment. I'll press this Start button. At this moment, it's already capturing. Note the green ring around the screen, and we're generating frames and points. Additionally, I can see that some areas already have points. The grey areas represent what the scanner sees. As I continue scanning, some points turn green. Notice that some remain red, but as they turn green, indicated by the quality control option, it means that area is fully defined. I need to move to reach areas where the camera cannot capture. There are zones with some red points and others without points at all. The red points indicate areas needing more information, requiring a slower pass or a second pass from a different angle. Some areas of the part are already fully defined. Now, I'm stepping slightly out of the zone, where I can visualize the part effectively. But I'm mainly watching that green bar to stay at the optimal distance while trying to show you what I'm doing. There's an area at the top I'll try to improve. Did you see that? The scanner lost tracking for a moment. Notice where the bar is. Too close to the limit, which is why it stopped. It likely exceeded the proximity limit. The message says, "Tracking lost, please move," meaning I need to move the scanner slightly away from the part. I've done that, and now we're back within the optimal range. I'll try to capture this area a bit better now, as I couldn't get it earlier, and maybe also the back of the piece. Now, you can't see me, but I'm trying to scan the back of the object, and now we'll move back to the front. And here we have the object, at least the part I intended to capture. Now that this part is captured and meets my requirements, it doesn't make sense, and you shouldn't continue scanning the same area, as it can lead to point overlap. Let's stop the capture. Now we encounter a feature of this scanner that I find very interesting. You can view the different frames captured during the scan. What's the advantage of this? It's not just to see a history. If you leave it at a specific position, and let's imagine that after this position something went wrong, you can simply go back to the good position and continue from there by pressing Start again. The scan will resume from that point. I'd say this is one of the advantages of having a company like Shining 3D behind the product. Another option would be to go back to the good position and accept the scan as final at that point. This is a common scenario because when scanning, there's always a tendency to do more than necessary, and the excess can sometimes ruin the result. In such cases, you can roll back. Other systems, like the one I have from RevoPoint, also allow something similar, though the implementation isn't as elegant. In this case, I want to keep all the captured points to retain all the information. Now, I'll zoom in a bit to show this part of the screen. Notice that we have some additional information here. Recalibrate. In grey indicates that the scanner was calibrated more than 7 days ago but less than 14 days ago. After 14 days, recalibration becomes mandatory and the colour changes to red. I'll grab my pointer again, and I can see through this first icon that we're currently scanning objects. The other mode, represented by a head icon, indicates portrait scanning. The H icon shows we're in HD mode, which is also indicated elsewhere on the screen. This diamond-shaped symbol indicates that alignment is based on the object's geometry. Just below, and I'll zoom in a bit more, we can see the frames per second. Currently 0 as I'm not scanning. A moment ago, it was showing about 13 or 14 frames per second, which is normal for HD mode. We've captured 861 frames, and below that, 4.7, indicating that 40,720 points were captured. Now, I'll accept this result and the scanner will switch to editing mode. In this mode, you can create a mesh directly on the device. I'll adjust the scanner to show what I'm doing while preventing it from slipping. I think this position is good. In this mode, you can clean up the points using the trim tool, which applies to the captured point cloud. I'll do this using the rectangular selection tool, which seems appropriate for this situation. I'll remove this entire area, the bottom section. I'll try again because the scanner started slipping. It was predictable. The idea is to eliminate all the points currently being selected, okay? New selection. Let's delete, and here's the result. I'll switch to rotation mode. As you can see, I've removed parts that weren't relevant. Remember, the component of interest is the blue one on top. I'm not interested in the base, as it's relatively easy to replicate directly in Autodesk Fusion. If we had texture, we could activate it here, and it would display the object with texture. This option would color the points. Keep in mind that we don't have a mesh yet for the texture to be permanently applied. The effect of applying texture to the point cloud can be seen in this other scan I performed with the option enabled. Once again, we have the tool that allows point selection after completing the process. Selecting Complete finalizes this step. It's obviously preferable to do this on a computer. In practice, whenever I'm scanning a part, I always have the computer nearby, making this feature more of a curiosity than a practical tool. In fact, I rarely take advantage of being able to do this directly on the scanner. There may be scenarios where it makes sense to use this feature, but honestly, I can't think of any right now. Perhaps for quick cleanup before resuming a scan, avoiding multiple exports to the computer, that could be a use case. However, this isn't possible because once you accept the model in this phase, you can no longer resume scanning. In other words, once you enter editing mode, you can't go back. I believe there are practical scenarios where using these tools on the scanner makes sense, but identifying those scenarios would require prolonged use of the scanner to observe such needs. I won't be arrogant and claim this doesn't make sense for anyone, as there are likely countless applications I'm unaware of. I also don't believe this feature was developed merely because an API was available and used as a tech demo. That said, the model will eventually be exported from the scanner. No matter how well finished it is, it will always go through the computer. At that point, these cleanup operations could be performed more comfortably, and with greater precision on the computer. I'll leave this area untouched so we can have something to work with on the computer using the software provided with the device. Let's finalize by selecting Complete. After completing the cleanup process, you can always reactivate the Clipping Data tool. There's no issue with that. Now we have two options: the wizard or manual mesh creation. My usual practice is to save and perform this task on the computer. The wizard makes the choices for you, which I don't use. The manual option allows you to define your preferences for mesh generation. It's important to note that the battery is at 44%. This will serve as a reference to see how much battery is drained by the end of the mesh creation process. Let's aim to complete it quickly. Regarding resolution, you need to be cautious. Why? Because if you increase it to the maximum, the device might not have the capacity to process all that information. And here we are. We're now seeing the message that confirms just that. In this case, you can scan, but you'll need to complete the processing on a computer using the StarVision software. Furthermore, the computer should have more than 32 gigabytes of RAM. If you use these parameters, you'll likely end up with a very large file, easily over 1 gigabyte, in addition to the time required for processing. So, I'll accept the recommended values and do what I usually do: reduce or completely disable mesh smoothing. The reason is simple. Enabling mesh smoothing results in a loss of detail, and this object already has details that aren't very pronounced. What would likely happen is that edges and other critical features would be lost. Another issue is the inevitable loss of dimensional accuracy. For this reason, I completely disable this option. The watertight option, when enabled, creates a closed mesh. In this case, given the application, it doesn't make sense to close the mesh. However, I'll show you an example of a model where I enabled the watertight mode and printed it. Notice this little figurine of my nephew Eduardo. Despite some flaws, it was printed entirely after being processed on the scanner. Before sending it to the printer's software, I activated this mode to close the holes in the mesh. There were small holes throughout the model and a large one near the feet, an area that wasn't fully captured. However, amidst all the folds, the flaws are barely noticeable. In the current case, this option won't help. Imagine what the software would do if it tried to close this model. It would likely connect random points, potentially making the situation worse by introducing issues like manifolds. I'll now do a quick check. The mesh resolution is set to 0.14 millimeters. The resolution relative to the distance between points was defined earlier. Let's start with the battery at 42%. As the process progresses, the scanner provides information about its optimal use. The mesh is being generated. See here, generating. This count isn't linear and may jump suddenly, but it shouldn't take too long, especially since I use the recommended parameters. Let's wait a bit longer. This way, you can also see in real time how long it takes to create a mesh on the device. Note that the battery remains relatively stable. Once this finishes, we'll be ready to view the model in mesh mode. The device even has a browser that lets you view previously scanned models. You can delete, rename, or open them to make further changes, whether to the point cloud or the mesh, effectively redoing all the editing operations we've been discussing. When this finishes, we'll be ready to export the model as a mesh to the computer. Although we could have exported the point cloud earlier, exporting via Wi-Fi is not currently possible. This makes sense given the file sizes. Even with Wi-Fi 6, you'll need to use a USB-C cable. My advice is to ensure the battery has a good charge before transferring files. Despite using a workstation, I sometimes get a Windows message saying the USB port doesn't have enough power to charge the device, which halts the transfer. Now we have the model. Notice the surface quality is quite good. I'll zoom in a bit so you can see the details. The slight waviness you can observe may be related to the mesh generation, but in reality, this texture is typical of powder coating. It's inherent to the process. At this point, we still have time to go back if we're not satisfied with the results. Reconstructing the mesh and making changes is possible at this stage. I'll do one more operation on the device, a measurement. Let's see the width of this piece so we can compare it to the real object. Also notice that we can now switch between points and mesh. This opens the door to recreating the mesh. The ability to perform trimming or clipping on the mesh is another noteworthy feature, as it's not always possible to modify models in polygonal mode. Here, it is possible. For example, if I want to remove that small section at the bottom, you might not be able to see it, but I'll show you. It's a tiny area that I can delete. When clipping the mesh, there's also a Select Through option, which allows you to select polygons behind the visible ones. This means that if I do it now, with a larger selection, it will select both the visible area and everything behind it. Another thing it does is add to the previous selection. Notice the magnifying glass feature. It's quite helpful. It makes using clipping viable on a screen this size, especially with touch input. Without the magnifying glass, your finger would obscure the selection area, making it hard to see what you're doing. Let's perform a measurement in this area. I don't want to measure the bounding box, which is the material block or volume of the object. I want to measure between points. I'll select a point in this area. Let's try again because I accidentally selected the wrong point. It'll be between this point, not that one. Now, let's select another point on the other side. Although it's not possible to align perfectly symmetrical points, we have an approximate measurement. 102.3 millimeters. There are specific metrology tools that allow me to select a set of points and obtain an average between them. But for this application, this result is excellent. Now, let's compare it with the physical object, the hole punch, and this will give us an idea of the scanner's accuracy. To clarify, I'm not using a calibrated caliper. In fact, this isn't even a proper caliper, just something basic that wouldn't be used for anything requiring high responsibility, but should ensure accuracy to tenths of a millimeter. So, for this purpose, it's suitable. Notice that we're getting 102.4 millimeters. Let's take another measurement. 102.3 millimeters. Things are going well. These measurements are very close within this sample. Again, we're getting close to 102.4 millimeters. Let's take a measurement slightly lower and approximately 102.6 millimeters. There we have some variation, but overall it's around 102.3 millimeters to 102.4 millimeters, meaning the dimensional accuracy is excellent. Here's our object. I'll now exit the measurement mode, zoom in a bit more, and go back. Now we can see this information again. By the way, in the measurement mode, you can view details about what's being measured on this side, where additional information typically appears. Once we're finished, Remember, we're just one step away. You simply need to click Save. Once saved, you'll have access to the mesh model on your computer. Notice that the device is ready to begin another scanning task, but that's not what I want. Instead, I want to view the various experiments I've done with this hole punch. This is the latest one, and it's the one I'll export to the computer. It will be processed in Autodesk Fusion, which is excellent for refining the mesh. From there, I'll move forward to create a model using the extracted geometry as a reference. Meanwhile, the battery is at 37%, a 5% drop during this period, which is not surprising. However, I'd like to clarify that with models containing more points, the battery would drain faster, both due to the extended processing time and the increased load on the hardware, including the CPU, SSD, eMMC, and ventilation systems. Now, let's consider scanning an object like this. This object is outside the range of what this scanner can handle. It's small with very fine details. I've tried different settings, and the results were unsatisfactory. As it stands, this coin cannot be scanned. What will I do? I'll apply a surface coating using this spray, which will make the coin surface white and matte. Just a light coating is enough. Notice that the coin surface has already lost its shine. Here it is. This substance is supposedly not hazardous to health. Previously, it contained titanium dioxide, a compound used in many products, including sunscreen. However, as often happens with substances that are labeled miraculous, they eventually get classified as hazardous. Now, I'll show the coin. This is the treated side. The treated area will become even whiter and stay that way for hours, depending on environmental conditions. Look at the treated side compared to the untreated one. I'll position the coin here. There it is. Let's try to scan it. As I move the scanner closer to the coin, we can see it there. I'll try to position it so you can follow along. The scanner's visible window is quite small. Now, we're very close, but it's not yet ready for scanning. Let's adjust the exposure, perhaps like this. Let's capture this coin under these conditions. When I press Start, the device warns me to hold steady, but notice, it's not clear whether it'll even begin scanning. Notice these bars. The scanner is questioning whether there are enough geometric features and it likely won't progress. Also, note that the scanner isn't creating frames, so no points are being generated. Check the top left corner for confirmation. Let's stop. In this case, we can try scanning based on texture alignment. The coin does have some texture, albeit subtle. I'll enable it, selecting to capture the texture. Now you can see what the texture camera is capturing. With texture capture enabled, we can now enable texture alignment. I won't use markers, so we're ready. Let's proceed with scanning. It's scanning. Notice the green border around the screen and an increase in frames. However, it's struggling, which is evident. I'll stop here and accept the result. The scanner will optimize what it has captured. I'll clean up the model and take advantage of the orientation. One great feature of this scanner is that it sometimes understands the object's orientation, though not always. I'll try to select an area because I know it supports selection through all points as we saw earlier. I'll delete this entire section. Done. Additionally, using the lasso tool, I'll remove this small area at the bottom, completing the process. Now, observe the point cloud. Do you really think this will result in something acceptable? Keep in mind that not all points are represented. We captured 587 points, which is very few for scanning. However, it managed to record 74 frames, noting the scanner can achieve about 13 frames per second. Notice the icons. The mesh is in high definition. The object capture was performed correctly. Points were captured in high definition. Texture was captured. Two alignment methods were used, one based on shapes and another based on texture. Performing this requires significant processing power, which is impressive for a device of this type. Let's attempt the final operation, setting the mesh resolution to maximum to see if we can achieve anything meaningful. Obviously, no mesh smoothing will be applied in this case. The settings are ready. It should process quickly. Although texture was captured, I'm not processing it. And there are a few points. It's already processing. Let's wait a moment. Here's the result. A very faint representation of the number 20. I'm not sure if you can see it. We can conclude that this scanner doesn't have the resolution required to capture this object correctly, which is expected. The object is very small with fine and shallow details. Someone conducting a superficial analysis might conclude that the scanner isn't good, but that would be inaccurate. The correct conclusion is that this object falls outside the scanner's range. Now, we can finally proceed to the computer.